Hello again. In this video, we're going to look at the last two exercises to be completed in section 1.4 on page 24 of your class notes notebook. So let's start with exercise 2. The value of an investment is given by this formula, 1,000 parentheses, which means multiplied by 1.10 to the t, that's raised to the t, after t years. So V is the value, so I'll be in dollars, and t would be in years. Find the average rate of change between t equals 4 and t equals 6, and interpret the results. So go ahead and try this one first. We're looking for the average rate of change, the same formula as the previous video from the last page, page 23. Actually, the formula's on page 22. And see if you can come up with the answer. Okay, here it is. This is the formula we're going to use. This is between A and B, for t equals A and t equals B. And we're going to let V equaling f of t, which is equal to 1,000, 1.10 raised to the t. So we're going to look at, we know that this is the A, this is the B. So we're going to look at f of the B, which is 6, minus f of the A, which is 4, all over 6 minus 4. So go ahead and plugging that in. What you get is a 6 here. The same thing, 1.10 to the 4, all over 6 minus 4, or if you want to call that 2, you're more than welcome to. And you can figure this out on your calculator. So I just figured each one of these out on the calculator. I subtracted them and got 153.7305 without rounding. You could also do this straight on your calculator without these steps. I'm just going to plug this in and plug in 1,000 times parentheses 1.10, and then raise it. I'll use the caret to raise and write a 6. Then I press the right arrow to get out of the exponent, press minus, and do it again. You have to be careful here. You cannot divide this by 2, even if you hit the right arrow after you type this, because you didn't put it in parentheses, and this is a long fraction bar. So what I'm going to do is I'm going to press enter, and I'll get the numerator first, and then divide by 2. And you get the answer. To interpret this, what it means, the value is usually in dollars. So I'm going to round this to 2 decimal places and say that the average rate of change is $153.73. I'm going to cut it off there. And it's per year, because this is in dollars. This is the value, if you remember. That's what the F is. And then the bottom is just the T's. It's just years. So that's how they get dollars per year, between the 4th and the 6th year. So let's now do the same thing. We did it with an equation. Can we do the same thing with a graph? If you have not tried this one yet, please go ahead and try it first, and then come back for the solution. The population P of t gives the population of a town in thousands after 2 years. Part A asks you to find the average rate of change of the population of the first 10 years. So that means we're looking for our same formula, but now the B is a 10, looking at 10, and the A is a 0. So the first 10 years means from A is 10 to B, sorry, from A is 0 to B is 10. And you really just have to estimate this. I might make a graph here. Let's call this T. Let's call this P, which is, or F of T. So when T is 0, so this is 10 here and this is 20, so that means this must be 5, halfway in between. And 10, you have to estimate that. It's somewhere between 10, you go vertically here, it's somewhere between 10 and 15. Answers will vary. You're just going to estimate. So maybe you might put 11, 12, 13. I'm going to say 12. But whatever you know, somewhere between bigger than 10, but smaller than 15 would be okay. So then I'm going to do this, and I'm going to get, maybe I should put the equals over here in case I need more room. 12, that's the F of 10, minus the 5, all over, I decided to move it over a little, all over 10. So that looks like 7 over 10, which if you do on your calculator is 0.7. So if you said 13, it might be 0.8. If you said 11, it might be 0.6, but around 0.7. What does that mean? This is in thousands, if you remember. So if if this is for instance, 5 means 5,000, 12 means 12,000. So 0.7, this means thousands, right? Or you do that on your calculator, 700 people per year. I guess we have to move it to the right a little. Per year. So the average rate of change is what they're asking for here. The average rate of change is 700 people per year in the first 10 years. Part B asks, does the population of the town grow more between 5 and 10 years or between 15 and 30 years? Okay, so I'm going to look at 5 and 10. So I haven't valued 5 yet. So I went and said it's about 7. Again, you can say 6, you could say 8, but I'm choosing 7. 15 is in between the 10 and the 20 here on the input. And if I go to the output, I don't know, maybe 15, right? Maybe 14.5. You could say 14, you could say 15. Sorry, 18. Right, 15 to 20. So that could be like, 17.5, 18, 19, somewhere around there. Going to 30, I'm choosing 24, somewhere between 20 and 25. So if I want to know how much it grew, right, what is the population at 10? We know it's 12,000. I'm going to subtract that from 5,000. Not going to look at a rate. They're not asking for a rate. They're just saying, what is the population? How much is the change in population between 10 and 5? So we know that that would be 12 minus the 5 is 7, so 5. And again, this represents 5,000. If you remember here, the population was in thousands, so this is 5,000. Or you could just write 5,000. So the population changed by 5,000 from 5 to 10 years. Doing the same thing from 30 to 15. F of 30 minus F of 15, which is 24 minus 18, or 6,000. So it looks like the answer is 15 to 20. It grew more between 30 years than it did between 5 and 10. But which one Part C is asking, and by the way, here's my explanation. Does the population of a town grow faster between the same two times, 5 and 10 or 15 to 30? When you go about faster, now we're talking about the rate of change, not how much did it grow, but what is the rate of change that grew? How fast did it go? Right, fast means like how fast are you going? On the freeway, you would look at your rate. So let's go ahead and do that. So this one's going to be like part A, between 5 and 10. So we're going to do the same 12 minus 7, but now it's going to be over 5. So it looks like 1 or 1,000. Now let's do the same thing between 15 and 30. So we use the same formula. We do the 24 minus 18, but now it's all over 15. So we're going to get 0.4 in our calculator. Remember, that's 0.4 thousand. So again, I'm going to do, I could write the word thousand, but I'm going to do this trick and write multiply by 1,000. So we know it's 400. And by the way, what are the units? This is per year, and this is per year. Oh, it's changed. It looks like this one is faster. That means the answer is here. Between 5 and 10 years is 1,000 per year. So that means that the rate between the 5 and 10 years is an average of 1,000 per year, and the rate between the 15 and 30 is only 400 per year. It did grow more, but there are so many years, 15 years compared to 5, that the average per year was less. And that concludes 1.4.